And we are live. So, welcome everybody to World Product Day 2021. Before we get started, just for those of you who are new to this format, on YouTube, let me draw your attention to the chat window to the right of your screen. Use this window to ask questions, and then we'll make sure they get to the speakers at the appropriate time. So just to get familiar with that, why don't you tell us where you are in the world? That is what county or even country you're watching this from. And we will see those comments coming through. So I want to first of all add our ProductTank hosts from around Ireland, and also want to introduce to you our speakers. Okay. Now, World Product Day, if I can just say for those of you who haven't seen it before, is it's 24 hours of product tanks around the world presenting. So product tanks, as you hopefully are aware at this stage, are in something like 200 cities around the world. And it turns out that 50 of them are actually doing meetups on this same day. And that's what has come to be known as World Product Day. Now, we here in Ireland are, of course, doing our thing, and it's the third year in a row where we have product tanks from Dublin, Belfast, Cork, and if I'm not mistaken, Derry, Donegal. We're co-hosting an event. Normally, we'd be in our physical meetups in the 3 locations, and we try and hook up somehow virtually. This time we're all at home, and it's a different vibe, but it's still nice to be representing product here again. So our topic for today is AI and product, and I'm delighted to say that we've got 2 eminently qualified and very interesting speakers lined up. More on those in just a minute, but just to sort of emphasize where we all are, I suppose there's some of us in Cork who are going to wave now. And there's a couple of organisers on from Dublin. Come on, Ben. And then
Hey folks.
from Belfast, we have Graham on his lonesome. All right, good. Now, and what I'm going to do is I am going to John, do you want to say anything, or Ben, about what's going on in Dublin these days, product-wise?
So it's been a strange and wild and wonderful last 18 months. We managed to do an awful lot of great product tanks last year, and we really got going. This year, though, with the new lockdowns in Ireland, it's been a bit of a struggle for all of us to kind of get things off the ground. But this is our comeback tour, so we're launching with World Product Day, and we have more talks in the pipeline for the rest of the year. So we're really looking forward in Dublin to getting the community back together, getting the band back together, and you never know, we might even have an open air product tank. Who knows?
Oh, awesome! That sounds interesting. And Graham, same for Belfast.
Thanks, Donald. So yeah, we've started the new year with a bit of a bang, and we have Eilish and Stephen as part of the team in Belfast, and we've basically had an event every month. Now we'll probably not be able to keep that up, but we're gonna try, and virtual, and hopefully things are opening up slightly ahead of Dublin and Cork, so we might be able to meet in person before then. But we're delighted to collaborate again this year. Hand it back to you, Joel.
So, Graham, you want to say a word about our sponsor for the evening?
Yeah, sure, thanks. So Aflac Northern Ireland are tonight's corporate sponsors, and they've donated to the Children's Cancer Unit charity based in the Royal Victoria Hospital in Belfast. So we've been working with companies and charity partners since the start of the year. And the idea is quite simple. Instead of the donation for beers, pizza, soft drinks for an in-person meetup, we ask sponsors to make a donation to a charity instead. And I know that all the other tanks on here would love for corporate sponsors to approach them, and hopefully we can all make a contribution to really good causes for the rest of the year.
Excellent idea. So would you like to introduce Mayukh?
Yeah, sure, thanks. So I saw a talk Mike gave at NTP Engage in Manchester a few years ago, and it was a light bulb moment for me as I was heading up product at an AI startup. Now, we won't dwell on the fact that I was 3 to 4 months into the role, and Mayukh clearly articulated what I was actually supposed to be doing as a product leader in that role. But it was a fantastic talk, and I first contacted Mayukh just over a year ago before lockdown. It's been a long time coming that we've had him on this, and the fact that he's speaking at a much larger All Ireland event is fantastic. So I'd like to hand over to Mayukh.
Thank you, Graham. Let me go ahead and share my screen and get started. All right. Hi, everyone. Yeah, just like Graham mentioned, my name is Mayukh Bhaowal, and I'm very thankful to all the listeners and the viewers who are tuning in, or those who would be probably watching this later recorded. So very thankful. Also, thanks to ProductTank, Dublin, Belfast, and Cork for giving me this opportunity to share my experience. And also thanks Graham Stewart specifically for inviting me to this. I'm very excited to talk about this. Like Graham mentioned, I gave an original version of this talk several years ago in MTP Engage Manchester. However, since then, things in this domain around AI and product management has picked up more momentum. So I have an updated version of this with some newer stories and some changes that has happened since I spoke about this last time. So I like to start this talk with some anecdotal stories. This was in Cambridge, Massachusetts, on a massive stage in front of several hundreds and thousands of audience. There was this ex-Stanford professor who was actually scribbling away on a whiteboard. It's surprising these days. He was talking about how AI is changing the world. And in the process, he said something which kind of caught my attention. He was talking about how traditional job descriptions are breaking down or crumbling away with the advent of AI. And that professor is, ex-Stanford professor is Andrew Ng, who is also a Coursera founder. And he goes on to talk about product management with a chatbot example and mention that traditionally a product manager would provide product specifications through wireframes. But for a chatbot, those wireframes are completely useless to the engineers because these are NLP engineers and data scientists. They would like to know the logic inside or the substance inside. Now, as the demand for such AI product managers has also on the rise, there's also the supply side of the story. How do you train product managers to start building the specifications for AI products? And there has been a huge rise in massively online courses on AI product management. And these are just few examples that I could find. There is one nano degree program from Udacity, which helps you to become an AI product manager. Udemy also has this program on the product management for AI and data science for 2021. And then there is an AI solutions product management course from the AI Product Institute. Finally, you might have all heard about him, Marty Kagan, who's the author of the book Inspired, and he's in the Silicon Valley Product Group, celebrated product leader. In a very recent talk, he actually talked about, dedicated a section more about AI and product management. And he mentioned how behind every great AI product is a product manager who needs to lead the vision, help with data, facilitated the work of technology teams, listened to customers, had empathy, and drove adoption and growth led by business metrics. So if you can follow on the theme here, with AI and ML on the rise, product management as a job description is getting transformed as I speak right now. Before I move forward further, I want to actually take a step back and set a little bit of context. Now, engineering as a discipline has been there for thousands of years. It dates back from the pyramids of Egypt to, I think, the military engines in the 1300 to the mechanical engine and the birth of the steam engine in 1800. In other words, it's an extremely mature and well-established discipline. Product management, on the contrary, is actually less than 100 years old. And the first product managers were managing brands. And funny enough, they were known as brandmen. And then it transformed into product line managers with the manufacturing industry. And with software came along Agile and Scrum. In other words, it's relatively, compared to engineering, I say a discipline which is kind of a baby compared to engineering. But we are all product managers. We are just not another baby. We like to think of ourselves as the boss baby. We are born to lead. Anyways, fifthly, moving on, it kind of reminds me of professional sports and how it has changed over the last 50 to 100 years. With video replay reviews in almost every major sports today, it has fundamentally changed how we engage and attach with sports, whether we're watching it in the field or the comfort of our home. And interestingly, some of these video replay reviews becomes very famous internet memes. So here's an example of Simone Biles, who jumped so high in the Olympics, she apparently reached space. And these days, she is doing other feats, like she's doing the Yurchenko double pike, as I hear. And then we have sports analytics, which was really popularized by the movie Moneyball. It's also changed how coaches were thinking about sports, how they were hiring players, how they were thinking about staffing of team and strategizing to win games. Though many of my female friends would joke about it, that you don't need sports analytics when you have Brad Pitt on the cover. I mean, that should just do it. To more professional or advanced sports equipment, every 4 years in the Olympics, I think we are going faster, stronger, and higher. And finally, to more women playing professional sports. I found this cover from Washington Post very bold, where it talks about one of the bars when women lead in male sports. So product management is like that evolving discipline. And as we are talking about it, there is a shift. And I used to say this 2 or 3 years back, that AI product managers are rising. But I should say that I stand corrected. The AI product managers have risen. Traditionally, as a product manager, we work with several organizational stakeholders like engineering, marketing, sales, design, DevOps. We're all aware of this. But with AI product managers, we need to include additionally more cross-functional stakeholders in our circle, namely the data engineer and the data scientist. In fact, as the AI product space have matured, some of these other disciplines are also having sub or micro disciplines. For instance, design is leading or giving way to something called conversational AI design, especially with voice and virtual agents and chatbots. And DevOps is kind of giving birth to a concept and more organizational roles like AI ops. So the stakeholders that we have to work together with to make the product successful has been ever growing. Now, with that context, in the next section, I want to talk about 5 concrete skill sets that we as AI product managers need to acquire to be successful. Namely, problem mapping, data is the new UI, acceptance criteria in the world of AI, explainability, ethics, and bias, and finally, how do you scale a product from research to production? So let's get started with problem mapping. It's often the case that with AI and machine learning and host of new sophisticated, fancy technologies there in the market, and sometimes there's a lot of executive pressure that we need to infuse more AI in our products. We as product managers forget about mapping those technologies and solutions back to the business problem that we are trying to solve, our customer pain point. I find it in my experience very imperative, especially with AI products, to be even more laser focused to do that mapping. And one way to think about it is actually force ourselves to think that can we solve the problem with traditional tools, non-AI, non-machine learning tools, like maybe rules-driven engine or a menu-based system. And when that does not lead us far, then only venture into AI and machine learning. So let me give a concrete example of an online shopping assistant, like a virtual agent. In this example, this is an e-commerce application where the AI product manager is actually helping the users who are coming on the site for shopping, finding the right item, like whether it's men's items or women's items, what kind of item, what price range, and make that purchase. So an AI product manager in the face of this problem should first think about like, how big is the catalog of items? If it's like 3 or 4 level deep, and if the only use case here to solve is like help the user to find the right product, maybe initially a menu-driven system like you're seeing on the screenshot will take us a lot farther. And what kind of deflection rate or what kind of resolution do we achieve using such a menu-based system? And then once you do that, as your product catalog grows, or if you're designing this for a system where the product catalog is massive and very complex, and you're not just doing shopping, but you're also helping with post-purchase. You're helping with orders tracking, you're helping with returns. Now we're talking about larger number of use cases and more complex catalog. This is a good time to start thinking about involving machine learning to understand the intent from the user's utterance or the phrases. For instance, the user, instead of navigating down the hierarchy, might just say, shopping for women's boots around $100. So the machine learning algorithm can understand that the intent is about shopping, and the entities here are women's boots, which is product, and $100, which is a currency. So instead of going through, if you remember the old school IVR system, like press 1, 2, 3, go through a very deep hierarchy, a machine learning system can help the user get from start to the goal immediately in one step, and thereby increasing the business goal here, which is the customer satisfaction, or CSAT. So this is a good example where the AI PM started with a menu-driven system, and then when the KPIs or the business goals that they were trying to solve, they could not achieve with that, ventured into an AI-driven system using intents and entities. And all the time, I think it's important to underline, keeping in mind, in this case, the business goal was CSAT, and how you can map that back to the solution. The next dimension I want to talk about is probably a huge dimension. There can be a talk by itself, but data is the new UI when we talk about AI products. Do you have enough data? Is the data easily accessible? How clean or messy is the data? Do you have to do some kind of a post-processing on top of the data? Also, do you have historical examples, often called labels in the machine learning world, for the machine learning algorithm to learn from? So all of these are important questions that need to be addressed, and these are completely missing in traditional, product management specification. They don't exist. So let's take an example of a general image recognition or image classifier. It might do great on classifying cats versus dogs, probably very high accuracy. But if you think about medical diagnostics in the healthcare sector and use the same algorithm to classify brain tumors in X-ray images, it would perform poorly. And the reason is the data set never saw that many X-ray images with the presence and the absence of tumor to learn from. Now, when I sometimes talk about this example, some people critique saying that these are two very extremes examples, that you're classifying or comparing cats and dogs with medical images. But if you do a Google search on failed image recognition, this image often comes up. So apparently, it doesn't do a very good job even in classifying a chocolate chip cookie as compared to a cute chihuahua. So I think you get the point. Data is new UI and data is new UX. The next thing that I wanted to draw attention is, how do you know when the AI product that you have built is good enough that you feel confident, you feel comfortable in backing and defending that it's time for it to go to production? Now, in traditional product, you might think about feature completeness, fit and finish, number of open bug counts, and so on and so forth. For AI products, in addition, we have to think about what is the data science metric, and more importantly, what is the value or the threshold of that metric at which point we feel good enough to launch this into production. So here's an example of a credit card fraud classification product. So we are trying to classify, you're using your credit card, you're scanning your credit card or tapping. We're trying to figure out which of these are fraudulent transaction versus benign. So here's an example of an ideal classifier, which classifies all the fraudulent transactions as fraudulent and the benign transactions as benign. But by now, I think everyone knows that this is kind of a utopian world. This is idealistic. It doesn't exist. In the real world, such a product might skew in two directions. First, it might miss classifying some fraudulent activities. As you can see here, 2 of the fraudulent activities were not classified. From a data science perspective, a data scientist would say this is high precision but low recall. So those are the data science metrics. On the other hand of the spectrum, it can overclassify. So in addition to classifying the fraudulent transactions, it might actually say that a benign transaction is fraudulent. I'm sure it has happened to all of us. Sometimes our credit card gets declined when we go to a foreign country. Now, depending upon the use case and the product, it's incumbent on the product managers to provide some guidance to our data science team which direction to skew. For instance, in this case, certain financial services company might say that for them, missing a fraudulent activity is way costly than introducing false positives. They're totally okay with that. So they would, in this example, bias or optimize for the false positives. So that's how we determine what the metric is. But then how do we think about what the threshold is? So going back to the chatbot example, so this is an example of Einstein chatbot from Salesforce. So we have this metric called F1 score, which is a little more advanced, which kind of takes a combination of precision and recall. But we also have in mind our business goal in this case is deflection rate. What is deflection? How many times a user has started a conversation, and of them, how many of them were addressed or deflected by the bot, versus how many actually went back to the human, or to a support agent who had to interact with the user to solve it. Because every time it goes to the user, it costs dollars per transaction. So deflection rate is a real business goal that we are trying to map back to. And so the AI PM, if you remember the example, should have a baseline deflection rate from the menu-driven system, and then determine what is the lift in that deflection rate that they're looking for. And then we can plot, so in this example, if you have an F1 score from 75 to 100, you get a deflection rate of 11%. If your F1 score is 50 to 74, you get 5% deflection rate. And we see what the baseline deflection rate here is. So if the AI product manager wants a 5% deflection rate, a machine learning algorithm with an F1 score more than 50 is good enough. You don't have to get a 98 or 99% accuracy. However, if they want a higher deflection rate of 11% based upon the business need, then they would probably target a higher F1 score. So that's how we would think about figuring out the threshold or the value of the data science metric by comparing it with the business metric. So over the last 5 years, I've been working on the enterprise space, building AI products, and I have to confess, one of the questions that our customers have asked us again and again is, why did the machine learning algorithm make the prediction or the decision that it did? It turns out that machine learning and AI, even though it's on the rise in many fields, customers have a trust issue. They don't know what's going on or why is it giving that prediction. And it's therefore we as AI PMs need to be thoughtful about how we can make the machine learning product more explainable. Because explainability leads to trust, and trust leads to adoption, and that's where we want to be. And there are several trade-offs that we might have to make in this process. Here is one example. It's a trade-off between explainability and accuracy. It turns out that simpler machine learning algorithms like linear regression and decision tree are highly explainable, especially when the data set is not very complex, but they're not very accurate. Whereas on the contrary, neural nets, which are used in deep learning models, the model is very, very accurate, but it's more black box in nature. So if I'm an AI PM and I'm building a product, let's say in a regulated industry like healthcare, or let's say legal, or even in Europe with GDPR prevalence, where there is a right to be able to explain in some cases, explainability will actually be a better trade-off than accuracy. Additionally, we also need to think about bias, the data sets that we are using. Is there some kind of a racial or gender bias that's creeping into that data set? Is it diverse enough? And this is actually one of my all-time favorite examples of that. This is Google Translate. And what you're seeing is on the left, we have a gender-neutral language, like Turkish. So they don't talk about he or she. It's gender neutral. On the right, we have English. And if you look at some of this translation, he is a soldier, she is a teacher. He is a doctor, she is a nurse. And if you go to the fourth paragraph, it says he is hardworking, she is lazy. So clearly, humongous amount of gender bias has kept into this machine learning product. It almost represents the 1960s career choices for women. But does that mean that we as AIPM just say that, hey, gender is a feature, we should not take that into account? Not so fast, actually. It's more nuanced. Although gender is probably not useful, actually it's harmful in this example. Or let's say if you're trying to do a job recommendation product where you're mapping candidates to jobs, it's actually extremely useful in healthcare if you're doing a medical diagnosis to figure out prostate cancer, because it only happens to men. So again, depending upon the use case and the product, we need to weigh in about which features are likely to cause different kind of bias and versus which ones are not. And if you're curious, Google Translate actually addressed this problem 10 years later after they launched Google Translate in 2018. So now for each of those gender neutral phrases, they're also showing both masculine and feminine translation, like you see on the screenshot on the right. So that's a creative UX way. That's why design also plays a very important part of actually solving this problem. Finally, I wanted to talk about scaling. Like many of we generally get started with pilots and research. Many of the components that make a pilot or a research successful might not be relevant when you're actually scaling to large, big systems. This is a very famous paper called The Hidden Debt of Machine Learning. And what it's trying to illustrate is only a small fraction of real-world machine learning systems is actually composed of anything to do with machine learning or data science, which is the little small black box you see in the center. Real-world systems, we need to provide guidance around, let's say, is your machine learning model will be on the cloud, or is it going to be on your device, on your mobile device? Because depending upon the use case, maybe privacy and security is important, so you cannot have it on the cloud, or maybe performance is important. Another example can be, is your machine learning prediction going to be real-time? Is it emitting real-time prediction, or can you just train it batch offline? Because a real-time system is harder to architect, takes more time than a batch system. Also, you have to think about ETL, like what kind of extraction, transform, and load you need to do on your data set before it's actually accessible to the data scientist. So as an AI PM, we need to slowly build this product spidey sense as to which products to go after. With this hindsight, which of them will make it to the production faster and to the market faster, to the hands of our users. Now, some of us who have worked in product management for several years, especially in the mobile and the web stack, you might be wondering that, wait, I have never had to deal with any of these specifications that I have been providing. And that's precisely my point. However, I want to say that there is a little bit of caveat. By the way, sorry, I forgot about this slide. So when we were talking about this scaling from research to production, we actually took a look at it at Einstein at Salesforce itself, and we saw an exactly very similar pattern. So moving on, the caveat that I was talking about, that some of us who have worked on search or advertising, AI products did exist even 2 decades back in those disciplines. The Google search suggestions that you see is an example of AI. The ads that you see on Yahoo is retargeting, an application of AI. The spell correction that you would see on Amazon is another example of AI. So those of us who worked in these domains, even 2 decades back, had to provide some of the specifications for our stakeholders, who, funny enough, probably were not called data scientists then. I'm told they were called research scientists or applied researchers. But what's happening is, with AI and ML eating software, more and more domains and verticals being pervaded with machine learning, the demand for these specs have grown exponentially, which kind of leads me to the key takeaway and the central message of this talk. It doesn't really matter how fancy your algorithms are sometimes, several percentage of accuracy here and there, or how cool your marketing demo is. The AI product chasm is likely to be a barrier against the adoption of AI. As machine learning and AI grows and eats software more and more, and the demand for providing such product specifications increases and working more with those different kind of organizational stakeholders is on the rise, we need to up-level our skill sets, and then only we can build products which solves concrete pain points and problems, rather than building another cool technology solution. So with that, thank you so much. I really appreciate the opportunity. I think we'll have some question and answers later, so I'll be around. Thank you so much. And I think over to Rob.
Thanks very much, Mayukh. That was actually really interesting. There was one question that came through before Rob joins. And to be fair, I think you probably answered it already, but the question was, I mean, how do you think about bias in AI, and what's been your experience in thinking and planning for it? You know, you spoke about the dangers and the need to be vigilant, I suppose. You know, do you want to expand on that at all?
I can. I love giving, I think, more concrete examples. The more examples we give, it relates. So as I was working on the conversational AI side of things, like we were talking about understanding users' intent. So to train the machine learning algorithm, you need to provide different ways a user might say the same thing. So let's say users, we are buying something online and we want the order status. So we say, where is my order? That's one way to say it, but some other users might say it in a different way. And if we don't include diverse group of people to come up with those training phrases, we might miss how certain people might speak about certain things. So that's another example. Like try to get people from different culture, different geography, different religion, different backgrounds, different educational qualification. And then you would see how different people will say different things, so that when someone else says something, we don't completely miss it and misclassify it. So that's another example how we have been working on making our data set very, very diverse.
Interesting. Okay. So listen, I know I've got a few questions as well, but I think that we will wait until, let me bring Ben on here. Sorry, not Ben, Rob. And I'll let you step away, Mayukh, and it's great you're going to hang around, and you'll be with us afterwards. So, oh, you know what? I want to let John introduce Rob. So.
Cool. Thanks, Donald. Thanks, Mayukh. That was a fascinating conversation and overview of an insight into the world of analytics through the eyes of someone who's been in for so long, and so fantastic. So I'm really delighted and thrilled to invite and present our longtime colleague and friend of mine, Rob McGrath. Rob has been working for the last, has worked with me in SAP, in IBM and Current back in the day. And for the last 6 years, Rob has been working with SAP in the SAP Analytics Cloud, working in predictive analytics. And Rob's most day job is working in predictive analytics and natural language generation. And I'm really excited to hear, Rob, because Rob, with your 6 years experience, it's going to be great to hear about a product manager working in data in the wild. So without further ado, I'll hand it over to you to take it away.
Thanks, John. So let me share. Hi, so first of all, good evening, everybody, and thanks very much to the ProductTank lads for inviting me to speak today. Really looking forward to talking about the experience of using AI in products for real in SAP. So I was interested earlier to see Moneyball presented on one of the slides. About 10 years ago, I read the book Moneyball, and it reawakened an interest in using data to solve real-world problems. And as John said, almost 7 years ago, I moved from IBM to SAP to work in initially predictive analytics. And for probably about the last 5 years, I've worked in business intelligence using advanced technologies like AI, machine learning, predictive, natural language to improve the analytic experience for users of analytics, so predominantly for business analysts and for business users who use analytic systems. So what I'd like to talk about this evening is some of the experiences we've had in doing that over the previous year, some of the lessons we've learned, and some of the thoughts I have around how you can effectively use AI in products. And it was interesting to listen to the talk earlier because I would never call myself an AI product manager, even though I guess I probably fit very well into that category. I consider myself to be a product manager. And AI is one of the tools we use to deliver features that solve problems for our users. So it's not about the AI or machine learning, predictive natural language, neural nets. Product management's about solving problems for users. And artificial intelligence and these other advanced technologies are exactly that. They're advanced technologies that allow us to solve problems we couldn't solve in the past, solve problems in a way we couldn't solve them in the past. They obviously allow us to make use of data, large amounts of data, process data quickly, do things like detect fraud quickly, do things like facial recognition, do really important things like analyze medical images more accurately and faster than humans can do it. So they're really, really powerful and they can add really large value. But the key to using AI successfully in products is to focus on the product and focus on the customer and focus on the problem. So I really encourage everyone to make use of these advanced technologies and to learn about them and to understand where they're useful and to understand the pitfalls. But the key is to think about the product and the customer and the problem. So when I started looking at this stuff, I thought it was going to create world peace and an end to hunger because it's very exciting. I read Moneyball and I said, that's how everything should be done. We should figure out, spot things other people don't spot in the data and use them to gain an advantage and to solve problems. And everyone is familiar with the hype curve. So like every other technology, AI, predictive, machine learning are all subject to this hype curve. And where you are on the curve is really, it's different for different products, it's different for different industries, it's different for different problems. For consumer products, I think we're very much in the plateau of productivity. So we all use AI every day. Our Google search is powered by AI. My phone tells me how long it'll take to get home from work, or it used to when I was able to go to work. We're exposed to these features. They're presented to us really, really well. We understand the output. When it matters, I think we understand, or at least we have some mental model of how it's figuring it out. So we trust it. And we're able to use it effectively. It's able to add value. And it's been quite successful. I think for B2B applications, for more commercially focused problems, we're further back along the curve. And we're in different places in different domains. We're in different places with different complexity of problems. And we have different technical triggers. So technology is moving on all of the time. New features come out, new technology comes out. You know, a couple of years ago, the big advancements in graphics cards meant we could do a lot more. Neural nets were a lot more accessible and could be used to solve problems a lot more than previously. All of these things create a fuss, all of these things create excitement, and eventually they find their way into useful products that solve real problems. So, three kind of main concepts to make these AI features useful in products. The first is that all of these technologies are complex. To be a really good data scientist, you probably have a PhD in statistics or data science. And in addition to the extremely complicated maths, it's a very complicated process. There's a need for a lot of skills in data manipulation, in Python, R, and so on, before you can really be effective as a data scientist. But if we want to make AI-powered features accessible to users of our products, they have to be really simple. The feature has to be provided in the right place. It has to be provided in a really easy way and in a context that the user can take advantage of it. It also has to be really understandable. We need to give the user an answer that they can quickly interpret, quickly understand, and make a decision based on. So we don't tell people about probabilities. We say, you know, the chances are high, medium, or low. We try and present information in a way that's quick for people to understand and won't mislead them. And the final part is to do with transparency, or as was mentioned earlier, the explainability. Depending on the context, this can be more or less important. So in some features, we don't really mind how it does it. We can kind of imagine how it might do it, but we're willing to take the advice and then by trial and error see is it accurate. And if it's accurate, we will start to rely on it. So a good example is the weather forecast. I really have no idea how they work out the weather forecast. I know it has something to do with measuring pressure and wind speed and the amount of moisture in the air, but I really don't mind. Through observation, I know how much or how little to trust the weather forecast. And like everybody, I have my favorite weather app on my phone, and I trust that more than I trust other weather because I think it's been more accurate. But I don't really know how it works. For more complicated or more vital problems, we need a higher degree of transparency because the costs of it being wrong are really, really high. So to give an example, there was a program in America, a product called Impact, that was used to evaluate teachers. And it was a machine learning algorithm that looked at the scores of students. And then after they'd been with a teacher for a year, it looked at the scores of students once again. And if the scores were consistently dropping, the teachers were identified as being bad teachers. And in 2011, 206 teachers in Washington were dismissed because the Impact program marked them as being ineffective teachers. But when people started to complain about this and people looked into the algorithm and started to explain how the algorithm was making decisions, the algorithm was simply looking at student scores a year before, student scores now, and then seeing whether there seemed to be generally an improvement or a disimprovement. But they didn't look at bigger factors, the social environment. They didn't look at, was it possible the teachers were gaming the system? So the teacher the year before could give everybody a high score so that they would do well, but then the following year the teacher would be at a disadvantage. And because it wasn't transparent and because the officials were just trusting it, it led to people losing their jobs and it led to a really bad outcome. A similar problem happened with a product called Compass that was used to evaluate if suspects in crime should get bail or not. And it turned out to have, again, judges tended to trust it because it's a really difficult decision to make. And when they were presented with an alternative that was powered by AI, they were glad to take it because it's such a hard thing to do to decide to give someone bail or not, that a system that seemed to have powers that could determine if someone was going to commit a crime was really useful, and they really wanted it to be right and they really believed in it. It turned out there was a number of problems with Compass. One was because of the data that was fed into it, it had some racist tendencies. It treated minorities differently because the data that was used to program it had treated minorities differently in the past. It led to a headline that said Matt is racist, which obviously is not true, but got a lot of press at the time. The other problem it had was it wasn't very good. Actually, its predictions were worse than the judges' own predictions. So not only was it enforcing previous bias, it wasn't giving very good predictions. So it's really important that we understand where these predictions are coming from so that people can ultimately be the arbitrators and people can decide if that's the reason I want to be making a decision on. Am I happy that my decision is based on those factors, or do I need to make the decision a different way? So I wanted to talk a little bit because probably most people haven't worked with AI or worked with data science in the realm of a product. So typically the process can be very complicated, but to look at it from a high level, typically we start off with a problem and we start off with some historical data. So we have a problem and we have some cases in the past where we've solved that problem or dealt with that problem. And then we go into a process of preparing the data so that we can use it to solve the problem, training a model, evaluating the model, and going back and preparing the data further and so on. And that normally leads us back to reassessing the problem and reframing the problem and going back and looking for different or better or alternative data so that we can better build a model that allows us to answer that question. Eventually, we'll come to a predictive model, so a model that we're happy can be usefully used to answer the problem. And someone I work for has a phrase that all models are wrong, but some models are useful. So really, we're looking for something that's helpful in solving the problem. It won't be 100% right. No predictive algorithm or AI algorithm is. Then we take our current data, we apply the model to that current data, and we start to get predictions. And that's the basic flow we follow when we use AI to solve problems. Another thing to bear in mind about this, though, is how is it used or how is it presented? And there are probably scores of ways it can be presented, but 3 very common ways that we will interact with AI. So we're all seeing the COVID forecast for the last year. So how many cases we're going to have, how soon can cases go below a certain number, so we're allowed to do certain things again, and so on. In that case, the data scientists working out those forecasts are following this basic process. And then they're producing a report with a set of numbers that people are consuming. And a week later, they're going back through the process, possibly using additional or better data and producing a new forecast and publishing it for people to consume. So it's a manual process in a way, even though I'm sure they're using products and tools and systems to do it, that allows them to build a forecast based on the best data they have and then present that to people to be consumed. A second way we interact with AI every day are online searches. And in that case, there's an algorithm that's learning all the time from it makes suggestions. Some suggestions are followed up by people, some suggestions aren't. That allows it to improve the algorithm. It allows it to produce better search hits. So it's a service that exists that continues to learn and continues to produce suggestions to people and will presumably get better over time. And has access to a huge set of data. So you can imagine Google service is going to have a massive amount of data that it can train its algorithms against. The final example that I want to talk about is if you have a HR application and you want to add a headcount forecast, so that for each department you can forecast what headcount will be over the next 6 months. In that case, the algorithm needs to work within the remit of the product. The algorithm needs to be able to train on the customer's data, and then it needs to be able to apply forecasts based on the customer's current data. And it needs to work in an almost automated way, separate from the data scientist, so that it can continue to be useful once the customer is online and using the product. And there are several other ways we could deliver a product, but the point of talking about these is that there is the data science process and there is the way you can use data science to solve a problem. But in parallel with that, when we start to add AI-powered features to products, we have to think about how it will be delivered and how that fits into the broader product and how people will eventually be able to use it in production and get benefits from it. So where does the PM role fit in all of this? So if we look at a very simplified picture of the PM role without AI, as PMs, we talk to customers, we analyze the market, and we identify valuable problems. And by valuable problems, I mean problems that are pervasive in the market and people are willing to pay to have solved. Then we start to design feasible solutions, and then we build products, features, and services that implement those solutions. Then we go back and we push those out to the customers in the market, and we start to look for more valuable problems as we go around the loop again. And as we go through that process, we have always interacted with other experts. So as soon as we start getting into the solution space and building the final solution, we deal with architects, developers, writers, designer, quality, and so on. And these people, these expertise, all allow us to find the solutions and build better solutions for our customers. Data science is really another part to that. It's another set of experts that can help us identify feasible solutions and build useful products, features, and services. And they're not the be-all and end-all of how we do this, because the data science is not useful without the architects, without the developers, without the quality. And more going into the future, the usefulness of those people is less without the ability to leverage AI and data science where required. So, as a PM working in this, you don't need to be a data scientist. So you don't need to have a PhD in statistics or data science. I think you do need to understand the general process, how AI works and how it can be used. where it can be applied. We all have to have an understanding of the ethics. Where is it safe to use this and where is it not? What are the pitfalls that we can fall into and how to look out for them? And the data scientists are also constrained by those things. But as PMs, from the start of when we start to look at problems, we need to understand those basic concepts so that we can bring those through in the process and ensure that we're doing things that are useful and we're doing things that are safe for our customers. So I'm going to walk through a really small example, and this really just reiterates what I talked about before. So how do you add AI to your product? So as a product manager, you start off with a problem. So again, if we take something in the HR domain, I want to identify employees that are at risk of attrition. So I go talk to my data scientist and he tells me he wants some employee data. So we go and we get the employee records and the data scientist starts to work on them. And immediately those other experts come into things. So the UX designer, the architect, all become involved in the process from the very beginning. And we start to develop the use case, the requirements, the constraints, the proposals, the requests for additional data, and all the other artifacts and things that happen in the process of building a product. And everybody interacts around those in the way that people contributing to a product always interacted. And it's through that interaction and through those constraints that a useful solution can be built. So a data scientist may have an idea for a really powerful algorithm, but if that can't be implemented in the architecture, it's not helpful. If the UX designer or the product manager thinks it's really important, as was mentioned earlier, thinks it's really important that we can explain the outcome, that limits what the data scientist can do. If speed is important, that puts limits on the algorithm and puts limits on the architecture. So everybody really works together to bring the solution through in the same way as we did before data science, and it's the same way as we'll continue to do. We just have this new, really, really powerful techniques and tools that we can use to solve problems we couldn't solve in the past. So success with AI, and this was a specific question I was asked, it's success for your product. So however you measure success for your product today is how you measure success for your product with AI. You try and meet the KPIs of the project, improve the customer's experience, do better as a product in general, do better as a company in general, and improve life for your customers as you always did, and use AI as a tool and a mechanism for doing that. So as a final point, as always with product management, we start with a problem. And a word of warning, let's add AI to our product is not a problem. Let's add AI to our product can be a goal for the company because it can be important in the sales cycle, it can be important with the analysts, it can be important for marketing, but it's not a problem you want to solve. Really what you want to do is you want to augment your product or augment your customer's experience. And AI and machine learning and predictive are ways to do that. Then you start to gather data that helps you solve the problem. You start to validate that the data is useful and brings you to a solution. And you start to see, can you explain the answer to the user? So can you provide an experience for the user that they can trust? And the last thing I really want to say about all of this, and I'm borrowing this from Tim Harford's book, but be curious. In all of these steps, when you start to take the data, when you start to validate, when you start to think about explainability, use your natural curiosity. There's loads of really good rules of thumb, and there's loads of things, loads of checklists you can use to understand is this bad. But the key rule is to be curious about it. Question everything. Question if the data is useful. Question if the solution is useful. Question if you're happy that that's how you're making the decision. And so on and so on and so on. If your goal is to augment your customer's experience and you're curious about how it works and you're curious about the data you're using and the solution you're providing, you're going to be successful with AI. And you're going to be able to improve your products and improve your customers' lives using it going forward. So listen, thank you very much. And I think I'll pass back to John or Donna now. Thank you.
Rob, that was fascinating, actually. That was really good. Thank you so much for that. What I will do is, I think, I'll bring everybody back on, and we'll start going through some questions. Some of the questions coming in on the chat will, I guess, be obviously for you, but give me 1 second while I just run through this here. Bring everybody back in. So there we all are. Can we all see? Lovely.
Yes.
So question and answer time. Okay. I'm going to start just because a couple of questions came in here during this, during Rob's talk. So from Tic-Tac-Toe, in AI, if we base future behavior on past behavior, how do we deal with the huge anomalies that change behavioral patterns forever? For example, COVID-19. I mean, it must have just shifted the paradigm, to use that awful expression. Your data goes out the window. You know, what do you... I'm going to start with you, Rob.
Thank you. So I say first and foremost, that's probably a question for a data scientist. So how changes in data impact the accuracy of the algorithms is probably a question for an expert in data science. The reality is not all the data we had in the past is now useless. Things have changed. Algorithms can be adjusted so that they can take account of sudden change. But I don't have a brilliant answer. I don't know that everything we did in the past is now we can't base things on that data. Some behavior has changed, and that's part of the process. Part of the process is looking at the data we had in the past and deciding, is that useful to answer the question going forward? And maybe we need to find new data, and maybe we need to imagine a different way to solve the problems.
You know, that's a great answer, and I particularly liked the way that you basically made the point, as Mayukh had earlier, that you don't have to be the expert in this. You know, data science is just another expert that you're going to be dealing with, along with your architects and your UX and your QA and all these people. So yeah, a great answer. Mayukh, you want to add to that, or your experience?
Yeah, first of all, I wanted to say that's a great question. That means like whatever we are saying is making sense to people, because that's a really good question to ask, because the data changed. One thing that I've seen that we have done is, once you create a first machine learning model, there is a saying that you have to retrain it, because even without COVID, your data changes. So your customers use it differently. So what happened with COVID-19 is there are many companies or organizations or products who were probably retraining after a year or something, so which kind of accelerated them to use the new data to retrain their machine learning models. So that's one way some of them were trying to address. A very concrete example, let's say for a chatbot on, again, e-commerce scenarios, there was this intent which none of the chatbot had before, which is curbside pickup. So now everyone has curbside pickup suddenly, or different ways people are asking the same question. So we had to look into the data and say, oh, your customers or users are asking, do you have curbside pickup? And so you have to take that data in and adjust the model to address that situation. I would also say some cases, like if you're really doing forecasting stuff, you can't really use machine learning anymore, because you don't have representative data set. Because if anyone is forecasting what's going to happen with COVID with using machine learning, I can assure you it's going to fail, because there is no data like that in that scale.
Yeah, and I mean, you made the point yourself earlier that about data being critical to the machine learning, and well, of course that makes sense. But I mean, for those of us who have yet to start down the whole AI and ML route, I mean, we have the data that we have, and it's not necessarily the right data. So I guess is that a barrier to starting? I mean, do you need to try and get the right data before you start, or is your advice to just sort of launch into it? And to the point of to the last slide that Rob had, you start, you still have the same problems. You probably don't have you have some data, at least enough to get started with, and you start thinking about validation and explainability and so on, and circle with the relevant experts, engage everybody in the problem. I mean, I don't know, I'm yabbering now, but
yeah, I can say a few things. I think there has been a lot of advancement in AI and ML as well. I think there are a lot of new companies and startups, even mature companies, who are working on how can you solve problems with. There was this whole trend about big data, But now there is a trend about how can you make things work with small data, because that's exactly what you're saying. Most of us, if you really want to get massive adoption, people don't have big data. Like we have small data. So how can you deal with? So there are some data augmentation techniques that has been happened a lot recently. And so I would definitely, talk to my data scientists, like, can we use small data to solve some of this problem? So that's one, using some data augmentation tactics. And very simply, one data augmentation tactic can just be like, you take a sentence with few words, you switch around words. I mean, very naive description. And so one phrase becomes two phrases right now, because sometimes people say things in different ways. So that's what I meant. There are some more advanced methods. The other thing I would say is there's also a lot of, we call it pre-trained model or global model. So this has already been trained in massive data sets that's available by bigger organizations. And so there is some advancement with machine learning where you don't have to start from zero. So you can take that model, which is trained on, if you remember the image recognition example I gave, so it has been trained on a large set of images, which has cats and dogs. But you can move from that to an X-ray much faster by using some concept called transfer learning, which your data scientists might be aware of. So what I'm trying to say is there is hope. First of all, small data is a big trend going on, and there are different tactics of making things work with small data.
Wonderful.
Donald, I just wanted to ask a question there, just as a lead on in the data. So, one of the things that we talk about is that you're looking at your own data, or you're looking at the customer data, and we've got that customer data. What's your view with augmenting that customer data with external event data? So, for example, contextual data about events in a geolocation. So it's St. Patrick's Day in Ireland. Therefore, there's going to be a spike in events queries. So maybe a customer service company might be having a spike in conversations coming in about that. Is that again similarly like the anomaly, and it's not really worth its salt, or is there actually value in that where you can augment your own data with those external events?
So the example that people often talk about there, John, is selling ice cream. So I have an ice cream shop, and I'm trying to predict how much ice cream I'm going to sell over the next week, so I can order my stock. Weather data is obviously going to have a big impact. So it's a really obvious example where if I add weather data to my ice cream sales, I'll see that on nice days I sell ice cream, and on wet days I don't. So that idea of bringing in external data sources is really common. And the data doesn't have to be complicated. The solution doesn't have to be powered by a neural net. It can be a relatively simple regression or classification algorithm based on a relatively small data set. And yes, of course, you can augment that with external data sources. And that can really add value to the solution without a huge degree of complexity. Quite often, the challenge with that is not the machine learning. It's not it's not finding an algorithm that can build a good prediction based on the data. It's actually bringing the data together, getting useful external data that you can blend with your own data source in production and use then to get a useful result. It's often more of a technical problem than a data science problem.
Interesting.
Can I just jump in on Rob's point about the ice cream and the temperature? Just that because I worked in a previous role where with a famous chocolate company, we were able to, with that temperature data, understand when people stopped actually buying ice cream because the ice cream was so hot that the ice cream was melting, and then people were buying milkshakes and so on instead. So I just thought I'd share that because it is interesting just how far you can go, and that's not a huge amount of variety of data sources.
Absolutely. I'm always struck by I mean the ice cream sellers in Cork need to be able to sell when it rains too. So I mean it's a just because they couldn't survive otherwise. Special kind of skill, no doubt. So there's a question here from Caroline again asks, how expert in AI do we think that PMs should be, or is it a case of understanding and leveraging the data science and other experts? Now, Rob, you've already, I suppose, spoken to that. Does anybody? I'm going to throw this question open to the tank organizers, see if anyone wants to jump in with an answer, and if not, I'll be coming to you, Mayukh.
Well, I certainly hope that you don't have to be a data scientist to be a PM, because I do hope to augment our software with data science, or rather with machine learning in time. But having worked in this space, I think the real skill will be for, like you spoke about, Rob, is to try and really match the problem first and going after looking at what problem do we want to solve and how then can we augment the solution to solve that problem, and not really trying to, as you put it, let's add AI to the product. So I think that for me is a personal learning growth that I'm going to be going after, is to look at how identifying the problem that can be augmented and not necessarily trying to go after everything.
Interesting. Anyone else?
Yeah, Donald, I suppose when I saw Mayukh's original talk, I was, effectively leading product in an organization with that, and I would say my biggest feeling there was I didn't have any experience, yet I was leading that part, the product in that organization, and I think that was probably a step too far. I think it's different if you were coming in, moving from a product role into a more AI role. I think that's something you can definitely learn and pick up. But to move into that and move into more of a leadership role where effectively AI, that kind of what you're doing is almost a value proposition. And I know AI is not the solution, but often it can be, like Salesforce Einstein, the value proposition, you could argue, even though it's not outcomes, but a lot of the secret sauce is around DI and ML. I would say that I think you do need some experience, at least, maybe not skill set, but experience in that background to take on that leadership role. That was my experience.
And did you have data scientists to work with, Graham?
Yes, yeah, I did.
Yeah, good. Critical, I'm sure. Ryan asks, other than Moneyball, do we have any other recommended reading or authors to get an initial understanding of AI as a PM? Now, Rob, you mentioned Tim Harford's book. Look at that.
So it's called How to Make the World Add Up. So Tim Harford is a columnist in the Financial Times that writes a really good article every week called The Undercover Economist. But it's not really a book about data science. It's a book about understanding statistics and using statistics usefully. But I think it has a lot of parallels to what we do when we add AI to products. And my Be Curious line is the closing paragraph of his book as well. I think it's really important. So that's a book I'd recommend people read as background reading around the area of using data to solve problems.
Excellent. And Mayukh, what are you reading?
From my perspective, I think AI and ML is kind of a leading edge. Some of these books are kind of lagging indicators. So generally, I read a lot of blogs, people who are writing in this space, more current stuff to stay up to date. And I talked about some of these courses earlier. So if you are more interested in how it's going to help you in your job currently, I would definitely recommend some of those courses on Udemy or Udacity. I think those would be useful.
Excellent. And does either of you blog, Rob or Mayukh? Or indeed John or Graham? Or anyone else who has spoken?
A little bit on the product, but not in the AI space so much.
Yeah, not a personal blog, but yeah, I write from time to time, but on and off.
Okay, well,
I think with the comments coming in, Rob, I think you might have a career in blogging. There's people looking to get a hold of where they can listen to more about what you have to say. So maybe it's a future career.
Yeah,
God help them.
There's a question here from Kaelan. Simplicity and transparency seem like they could be contradictory in some cases. Have you found this in your experience, and how have you dealt with it? Simplicity versus transparency.
That's a great question. And it's not that easy to answer. Well, sorry, I can give an answer, but it's a conflict. So what I meant by, and I think in some ways it's more the understandability and the explainability of the conflict. So when I had my 3 points, the simplicity is that the way you let the user launch the AI or interact with the AI should be almost seamless. It should be delivered in context to the user. So if I'm going to use that example on my phone, when I'm leaving the office in the evening, my phone tells me how long it's going to take me to go home. I don't have to do anything. It's a really, really simple interaction. The conflict is really between giving me information that's understandable so I can consume it quickly and make a decision, but on the same hand, when it's necessary, providing that degree of explainability so that I'll trust it. And there isn't an easy answer to that. It's hard to do both. And that's why usability and UX and designers are so important in this space, because you have to find good solutions to provide the explainability without making it so complicated that nobody can understand it. And I don't know, Mayukh, if you have anything to add to that, because you raised the same point, I think, in your slides.
No, I totally agree. It kind of, there's a saying that never let facts get into the way of a good story. So it's not that you're lying about stuff, but you don't have to talk about every single details there. I think it's a kind of a similar picture when we think about providing explainability. Like there's also a little bit of difference between enterprise and consumer here, by the way. So in consumers, I think the explainability is sometimes less important. You can see if you're shopping on Amazon, or sometimes they would say, oh, these are your recommendations. Or if you're using Netflix or HBO Max or Amazon Prime, these are your recommendations based on some of these other movies that you have watched before. So they're trying to guide you some examples, but I'm sure they have a lot more information why that thing is being recommended, but they are suppressing it on purpose. Whereas on the enterprise space, I think it's a little bit more higher demand, like where they actually want to know every single details why certain things has been recommended in many use cases. Or even the example you talked about, Compass, like that's a very well-known story. There, I think people, when those kind of things happen, I think people would like to know if the impact is high, if someone is getting a death sentence or being denied a bail or a mortgage, which would affect their life, I think they would like to know every single thing, why the decision was made.
Yeah, for me, I'm struck by the notion of I also struggle with this notion of explainability versus accuracy, right? And I guess part of me is thinking that, well, if the results are accurate, you wouldn't really need to rely on the explainability. I mean, the example that one of you gave was that explainability leads to trust, leads to adoption, right? But obviously, accuracy is another blocker to adoption. I mean, or inaccuracy would be a blocker to adoption. So I mean, I don't think there's a quick answer, but I guess at some point you're going to have to try and strike a balance in order to get a product out there, and again, focus on the problem, I suppose, is probably the answer, is it?
Yeah.
Yeah.
Is there another point? Sorry, Rob, go ahead.
The good news on that is, as product managers, is something we've been doing forever. So there's always been a conflict between, so in the usability sphere, there's always been a conflict between giving people something that's really easy to use and something that's fully featured. So if you take away all the buttons, it'll be much easier to use, but it can do a lot less. So if you look at like Adobe Photoshop, it's a wonderful product if you can spend 3 months learning how to use it. So it really comes down to who you're targeting at and how much those things are important. So back to that case was mentioned there a moment ago about consumer and business oriented products. Sometimes the explainability is not that important, and sometimes it's vital. And that's key to the product manager, to try and know where to strike that balance. And there's never going to be a right answer. So with all of these things, it's just trying to tread the balance as best you can.
Yeah, it makes sense. Go on, Mayukh.
No.
Okay. All good. I've just realized I haven't checked with all of you when you need to drop or whatever. But look, we'll keep on going. And if you need to shout at me and tell me you need to leave, then that's fine. There's a question that came in from Paul. Says, in the way organizations have an in-house legal counsel, should they have an AI counsel or AI Sherpa to bridge the gap between the business and IT? Has anyone ever heard of such a thing? No one here, sounds like.
I wouldn't say specifically. It's an interesting question. Not specifically like an AI counsel, but in some of the domains, like our legal team also needs to understand that they are working or they're giving counsel on an AI product. Coming back to the thing that we have been circled probably 50 times now, the data angle is important. Because these days, like, things are on the cloud. If your customer data is being sent somewhere else, like let's say Google or Amazon, they might have to write that in some of the contracts and stuff so that the customers are aware of. There are examples, without saying names, there are certain e-commerce vendors, let's say they want to not use their competitor product or send their data there. So there are examples like that. So yeah, from that perspective, I think it's important and I see more and more legal folks are getting more trained and more knowledgeable how AI impacts their roles as well.
Yeah. I think we're all going to have to, evidently. Listen, I'm struck by one thing. You with the model you showed, Rob. You showed the trough of disillusionment, and I love the expression or whatever. And I guess that's probably a thing with all products, right? But I mean, when it, when it happens, what are the key assets or skills or something that you need to get through that? Is it leadership support, or is it a promise of things improving, or
So first of all, I won't take any credit for it. It's the hype curve. I think it's Gardner's curve originally, and it applies to almost every technology. So people get excited about a technology. It's going to solve all the world's problems, and people hit realism. I don't know that there's any particular skill set in getting through what they call the trough of disillusionment. It sounds like something from The Princess Bride for people old enough. But I don't know if there's any particular skill set. I mean, obviously, sponsorship is really important. Adding AI to products is not simple in most cases. It takes a good degree of commitment. It takes particular skill sets that may not exist in the company, and it may not be successful the first time. So it will take executive kind of support and high-level support in the company to bring this through. And if people are not committed to it, there'll always be reasons to turn back. But that'll be the case for every technology you introduce.
Yeah.
Could I expand on that a little bit and ask Mayukh a question? Because he talked about the crossing the chasm, and having been in scenarios with this, I found this is the biggest challenge. So under the two scenarios as a product person, the first is exactly as you presented. You've done the kind of cool demo. You've probably oversold the potential and what you've been able to do and so on. That's the first scenario. The second scenario is where the product person isn't involved in all of that work, and then they're brought in to cross the chasm. It's almost like the old school UX thing where you bring the UX person in just to apply some design touches, at the end. And I've seen both of those scenarios, and as a product person, they're very, very difficult.
Yeah, I would say I think this goes back to organizational support and leadership support, is also kind of under explaining or educating the leaders in the organization that there are some steps to doing this. It's not a magic bullet. You just don't press an AI button and suddenly everything gets smart and intelligent. I'm glad some of them are understanding they want to add AI. So a few years back, that was not there. So we're making progress in the right direction. Maybe through that curve it's going through. So I think the more and more they get there, where they start building the product, and they would understand that there is a life cycle to that product as well. And these are all the organizational team members who are needed to make it successful. Yeah, sure. You can start with one data scientist. You can start with one PM and one designer. But then you have to start growing the team and to make progress to go past the chasm. And I think product is crucial there. So there has been, I've seen in my experiences, there have been some research projects where, that's why I said cool technology solution. Yes, this is great, but what commercial application do we have? And we didn't. And so some of them didn't really move far. One way I try to say this, like once you have the commercial engine going, it kind of provides a fuel for more research and stuff a lot. So instead of trying to do research and finding something which will fit it. I think search and advertising are two great examples of that, because those are the commercial engines. It moved away from academia to private companies, and they were putting money in it. And so there was a lot of research done, and there were a lot of improvement which happens as a result of that.
Yeah, fascinating. Look, I mean, I've found this entire presentation to be thoroughly educational and illuminating. Does anyone have any final questions for our speakers, or will we let them relax? If I quite enough for one day. Okay. Well, look, what I will wrap up with is this. I'm going to yeah. Okay. One second. Just going to move all that over there, and I'm just going to add this, and I'm going to remove. And say goodbye. Have we lost anyone? Yeah, we got everybody. I feel like I've lost somebody. Anyway, okay. All right. Bye, everybody. Thank you for
Thanks, everyone.
watching.
Thank you so much.
Right.
Thanks, Rob. Thanks,
Bye.
Mayukh.
Thanks,
Thank you so much for
Mayukh.
giving us your
Thanks
time.
very much for having us.
Thank you.
It's great to have you. Thank you so much.